What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the domain of several different types of functions, all right? So here, the first example we're going to go over is g of x is equal to 1 over x plus 5, all right? So remember, the domain of a function is basically all the numbers you can plug into the function without breaking some rule, okay? So for instance, as you can see, this function right here is a fraction. So the one thing that you want to keep in mind with a fraction is that you can't divide by 0, right? You can never have the denominator be equal to 0. So for this function, we can plug any number in for x, except, in this case, -5, right? Because as you can see, if we plug in a -5 right here for x, we would have -5 plus 5, which is equal to 0, right? So then this function would be equal to 1 over 0, and again, we can't divide by 0, right? That is undefined. All right, so there's a few different ways we can write the domain of this function. First of all, we could say that the domain can be all real numbers, any real numbers, that's the symbol right here, for all real numbers, except x cannot be equal to -5. Okay, so this is one way we can write what the domain is, all right? The other way we could write this is we could say that the domain is equal to, we could write it as an interval. So instead of saying all real numbers, we could write it as the domain goes from -infinity to +infinity, except again, x cannot be equal to -5. Or a slightly more appropriate way of writing this is by combining this into a union statement. So we could say that the domain basically goes from -infinity to -5. But we're not going to include -5, that's why we're putting a parenthesis right here instead of a bracket. And let's scoot over a little bit. We would say that's going to be in union with -5 to +infinity. All right, now here is the next example. So we have h of x is equal to the square root of 4 minus 3x. Okay, so one thing that you always want to keep in mind when you're working with square roots is you can't take the square root of a negative number, okay? So whatever you have in here, so let's just rewrite it. So we have 4 minus 3x, okay? Whatever this is equal to, it can't be equal to a negative number. It has to be equal to either 0, right? Because we can take the square root of 0, so it's okay if this is equal to 0, or it has to be a positive number. So the way that we can write that is this thing right here, 4 minus 3x, has to be greater than or equal to 0. Okay, so in order to solve for x here, let's add 3x to both sides. So then on this side, they kill each other, and we're left with 4 is greater than or equal to 3x. Now solving for x, we can get rid of this 3 by dividing both sides by 3, right? So then these die, and we're left with 4/3 is greater than or equal to x, right? Or we could flip this, right? We could say x is less than or equal to 4/3. Okay, so if we wanted to write the domain of this function right here, we could simply write this, this inequality. So x is has to be less than or equal to 4/3. Or another way that we could write this is we could say that the domain has to go from -infinity to +4/3, and we can put a bracket around the 4/3, right? Because we're including the 4/3, right? Because we have this equal to symbol right here. So whenever, again, just as a reminder, if you have just a less than or greater than symbol, you use parentheses, but if you have that equal to symbol attached to it, you use a bracket. Okay, so in any case, either one of these answers right here would work. All right, the next two that we have here are f of x is equal to 5x squared plus 2x minus 1, and g of x is equal to 1 minus 2x squared. So as you might notice, these are both quadratic functions, right? And you can tell that because the highest power on both of these is a 2, right? So this is the highest power on this function, and this is the highest power on this function. So they're both quadratic functions. And for any quadratic function, the domain is always defined, all right? So that just means you can plug in any number for x. It can be positive or negative, it doesn't matter, they're all gonna work, okay? So the domain for both of these is gonna be the exact same for all quadratic functions. It's always gonna be that the domain goes from -infinity to +infinity, all right? Nice and easy, just how we like them. All right, now the next one we have is f of x is equal to the cube root of t plus 4. All right, so one important thing to remember is you can take the cube root of both positive and negative numbers, okay? So knowing that, that means this variable t can be any number, both positive and negative, and it'll be totally fine. We can take the cube root of it, all right? Now, on the other hand, remember, you can't take the square root of negative numbers, all right? So then that would be different. But with cube roots, it's totally fine, all right? So since this t variable can be any single number, then that means that the domain, again, we can write it a couple different ways. We can say it can be all real numbers, or we can say that it goes from negative infinity to positive infinity like so. All right, the next one we have is g of x is equal to 1 over x plus 3 over x plus 2. All right, so again, as you can see, we have a couple fractions here. So that should be ringing alarms in your head, right? Beep, 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 beep. What can't happen here? We can't have the denominator be equal to 0, okay? So for this first fraction, 1 over x, we can see that x, right, we can say here, x cannot be equal to 0, right? Because if we plug in a 0 here, well, we're going to have 1 over 0, and we can't do that, okay? Now, for this other fraction, 3 over x plus 2, what can we not plug in for x? Well, for this fraction, x cannot be equal to negative 2. Okay, so we can write that the domain, we can again use interval notation, all right? So x can be any single number, both positive and negative. It just can't be 0 or negative 2, okay? So here we're going to say the domain can go from negative infinity to negative 2, and then we're going to put a parenthesis around this negative 2 to show that we're not including negative 2 as part of our domain, right? And then we're going to put our union symbol, and then we're going to say the other interval that we can include goes from negative 2 to 0, right? So we can go from negative 2 to 0. We can include those numbers between there. But again, we're using parentheses to show that we're actually not including those two numbers. And then lastly, we're going to say union. And then this last interval is going to go from 0 all the way to positive infinity. All right, so this big old interval is our domain. All right, here's the next example. So now we have h of x is equal to 6 over x squared minus 4x, all right? So again, we have a fraction, right? So that means the denominator can't be equal to 0, all right? So in order to figure out what value of x makes the denominator equal to 0, we can simply set this equal to 0. So we're going to say x squared minus 4x is equal to 0, and now we're just going to solve for x, okay? So the first thing that we can do here is actually factor out an x term from both of these terms, right? We can factor out an x, so then inside these parentheses, we're going to be left with, looks like x minus 4, and that's equal to 0, okay? Cool, so now that we factored it, now we just have to set each of our factors equal to 0. So we have two factors here, right? We have just x, and then this thing in parentheses, x minus 4. So we're going to set both of those equal to 0. So first we're going to say x is equal to 0, and then we're going to say x minus 4 is equal to 0. Okay, so solving for both of these, well, the top one, there's nothing to solve for, basically just gives us one of the solutions, right? We know one of the solutions is x is equal to 0, but down here we can see that the solution for this x would be positive 4, right? So then here we can say that x must be equal to positive 4. So we have two solutions here, right? X is equal to 0 and x is equal to positive 4. So those are the two numbers that would make this denominator equal 0. Okay, so here, remember x can't be equal to 0 and x cannot be equal to a positive 4. So if we wanted to write the domain, let's scoochy over a little bit over here. We're going to say that the domain is going to, we can plug in any number for x, right? Just not 0 or positive 4. So we're going to say the domain goes from negative infinity to 0, and then we're going to say union from 0 to 4, and then union from 4 to infinity, right? 4 to infinity. Boom. All right, so now we have basically a combination of a couple things, right? So for this function, we have f of s is equal to the square root of s minus 1 all over s minus 4. Okay, so a couple things here. On top, we have a square root. Now remember, square roots always have to be equal to either 0 or positive, right? So whatever we have inside of this square root, let's write it over here, s minus 1, whatever this is equal to, it has to be equal to 0 or it has to be bigger, right? So s minus 1 has to be bigger than or equal to 0. Okay, so here if we solve for s, right, we can just add 1 to both sides, those die, and we're left with s is greater than or equal to positive 1. Okay, so this is part of our domain. Now, the other thing that we need to check is the denominator. So again, this can't be equal to 0. So what number would make the denominator equal 0 here? Well, that would be a 4, right? So here we have to say that s cannot be equal to 4, okay? So there's two kind of conditions that we have to take into account here, right? S has to be greater than or equal to positive 1, but it can't be 4, okay? So it can be any number greater than or equal to positive 1, but it can't be 4. Okay, so here we can say that the domain, let's see, what's the smallest number that our domain can be equal to? Well, it would be positive 1, right? So, and we're gonna include positive 1, right? Because we have our equal to symbol right there. So the domain, the smallest part, would be a positive 1, and then that's gonna go all the way up to positive 4, but we're not gonna include 4, right? So it's gonna go from 1 to 4, but we're not gonna include 4, so we're gonna put a parenthesis around it. And then we're going to say union, but it can be any number bigger than 4. So then here we're going to say it goes from 4 to positive infinity. All right, so that would be the domain right here. All right, here's the last example we're going to go over. So we have f of x is equal to x plus 2 over the square root of x minus 10. All right, so again, in the numerator, this x can be any number, both positive or negative, so there's no issues up there. Again, what we need to look at is the denominator, okay? So just like the last problem, as you can see, we have a square root, right? So whatever we get in here, so let's write what we have inside that radical. So it's x minus 10, okay? So whatever this is equal to, it has to be equal to 0 or a positive number. So we have to say that this thing has to be greater than or equal to 0, okay? So here, solving for x, we can add 10 to both sides, right? So then here we get that x has to be greater than or equal to positive 10, okay? Any value that we plug into this square root has to be greater than or equal to positive 10. Now, the other thing we have to be careful about is making sure this square root doesn't equal 0, right? So what number would we have to plug in for x that would make this equals 0, because it would make the fraction, right, the denominator of the whole fraction equal to 0. Well, that would be a 10, right, because 10 minus 10 is equal to 0, and so then the square root of 0, again, is equal to 0. So here, even though the square root can be greater than or equal to 10, the fraction part of this whole thing can't be equal to specifically 10, right? So again, here we're going to have to say that x has to be explicitly bigger than 10. Okay, so again, this would be our domain. Or again, if you wanted to write this in interval notation, it'd simply be from 10 to positive infinity. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.